Okay, so first question we'll take a look at is reviewing whether a coordinate that they give you is a solution to a system. So to check, all we have to do is plug in the two numbers for x and y and see if we get a true statement. First thing we want to make sure is when I give you the point -1, -6, which one is x?
The -1.
Yeah, so that's x, and the -6 is y. So let's fill them in and see what we get. Okay, the top one, we've got -1 plus -6. And what I usually do is put a question mark because we don't know if it works yet. We're checking if it does. And what's -1 plus -6?
-7.
-7. So does that coordinate work in the top equation? Yeah, because we got a true statement. Okay. Let's check it in the bottom one. When I fill it in the bottom, what is that equation going to look like?
-1 minus -6.
-1 minus -6.
In parentheses. The -6 would be in parentheses, right?
You can put it in parentheses, or if you write it like that, that's okay too. Because what's going to happen there?
It's just going to turn into positive.
Yep. So -1 plus 6. Okay. Does -1 plus 6 come out to 5?
Yeah.
Yes. So that means that that coordinate is a solution to the system. All right, so next one we're going to take a look at is substitution. And the goal here is to look for an equation that has a letter with a single number 1 in front of it and try to solve it for that. Do we have an equation here that has a 1 in front of a variable?
The first equation.
Yep. So which letter would it be easiest to get by itself?
X.
X. Yep. So if we solve that top equation for x, what would we get?
8y equals 35 minus x, right? Or x equals 35 minus 8y.
35 minus 8y. Yep. So now we got x by itself. What are we going to do with the 35 minus 8y?
We're going to plug it into the x on the second equation.
Yep, we're going to fill that in right there. And remember, when you plug that in, it's a distributive property because that 6 is outside of the 35 minus 8y. So we've got 6, and we've got 35 minus 8y plus 8y equals 50. All right. What would be our next step?
Distribute the 6 to the 35 and -8y.
Yeah, so we'll distribute that out. And 6 times 35, that's going to be, what, 6 times 30 is 180. 6 times 5 is 30. 180 and 30 is 210. So it's going to be 210. And what's 6 times -8y?
-56y.
That would be 6 times 7 would be 50. Wait a minute, 6 times 7 would be 42. What did you say?
56.
56. No, 7 times 8 would be 56.
My brain. 8, 16, 24, 32, 28, 56.
So 7 times 8 would be 56.
So it's
6 times 8.
6 times 8. So it'd be 48.
48. And it's negative because it's positive times negative. So negative 48y plus 8y equals 50. All right. And what would we do next?
Combine like terms.
Okay, and what are my like terms?
-48y and then the 8y.
Yep. And when you combine those, what do we get?
40, -40y.
-40y. All right. And what would you do next?
And then you would subtract the 210 from both sides.
Subtract 210 from both sides, so that's gone. And what's 50 minus 210, or think of it as 210 minus 50 and then put a negative.
Yeah. 160.
160, but it's going to be
Negative
a negative 160. Okay, so we got negative 40y equals negative 160, and the last step.
You would divide by negative 40 on both sides.
Divided by negative 40. That negatives are gone, 40s are gone, and we get,
Y equals
yep. Okay, so we have y equals 4, and are we good? Are we all done?
No, we have to plug the y back in to get the x.
Yeah, so take this, fill it back in. The easiest one would be the one we already have right there with x by itself. And that's going to give us 35. What's 8 times 4? 32. So x would be how much?
3.
3. So x equals 3. All right, any question on that one?
In my portable multiplying skills.
Oh, that's okay, we got it. All right, so next question is similar to the last one. We're solving, again, we're going to use substitution, but this time it's a quadratic. All right, so let's just erase that. Do we have an equation with a variable already by itself?
The second equation.
Okay, what letter is by itself in the second one?
The y. No, wait. The first equation, the y is by itself on one side.
Yeah, so since we already have y by itself, we don't have to worry about solving it for y. So y equals 3x squared, and what are we going to do with that?
Plug that into the y in the second problem.
Yep, I'm going to fill that in for y right there. So we're going to have 12x plus 3x squared equals 15. And what kind of equation is that?
A quadratic.
Yeah, that's a quadratic. So because it's a quadratic, we want to get it equal to what
Zero.
number? Yeah, get it equal to 0. What would be the easiest way to get that equal to 0?
Subtract the 15 from both sides.
Yep. So I'm going to write it as 3x squared plus 12x minus 15. And do you see anything we could do there that would make our numbers a little bit easier to work with?
Divide by 3.
Yep, we can divide everything by 3. So x squared plus 4x minus 5. Now, once we have it as a quadratic, there's 2 main ways we solve quadratics a lot in this class. What's one way you can solve a quadratic?
The quadratic formula, and then you can do, I forgot what the other one it's called, but you basically make 2 parentheses.
The parentheses, yeah, factor.
The factoring, yes.
So I would say the factoring here is probably going to be easier if we can do it that way. So let's try it and see what happens. What would be your first term in each set of parentheses?
X.
It would be an x, yep. X and x. And what would be 2 numbers that multiply to give us 5?
5 and 1.
All right, so 5 and a 1. And what would our signs be inside parentheses? Because we had a positive and we had a negative.
It would be positive plus 5 and minus 1.
Okay, so let's check it. So we got x squared plus 5x minus 1x gives us 4x, and that looks good. So we've got everything factored. Now we just have to solve for x. What would you plug in for x in the first set of parentheses?
1.
Okay, so we'll call that our first x value. And what would you plug in for x in the second set of parentheses?
Negative 5.
-5. Okay, so we've got both of our x's. What do we have to find now?
We have to find the y.
Yes, we have to find both of the y's. So we're going to need y1 and y2. which equation would be easier to plug back into to get y? Top or bottom?
The top.
Yeah, because it already has y by itself. So we just have to square the number and times it by 3. So what do you get if you square 1? 1, and then times it by 3.
3.
Okay, there's that one. And now square that number,
25.
25 times 3,
75.
75. And there are your 2 answers for that one. So this one was a quadratic, so it has 2 pairs of answers for a total of 4 numbers. All right, the next question we're going to look at is still solving a system, but this time it's using elimination. So the goal is to eliminate one of the variables. And which variable do you want to try to eliminate?
The x.
X. Okay, if we're going to do that, we need the numbers in front of the x's to be opposites. How could you make them opposite?
Multiply the top one by -7.
Yep, so multiply the top by -7. And what did that give you when you did that?
-7x minus 56 equals -133.
Minus 56, and you had a y with that too,
Yeah,
right?
the y.
Okay, and there you had, what was it, negative
133.
133.
The right check that.
Okay.
'Cause,
And then what did you do to the bottom one?
I did nothing. I kept it the same.
Yeah, we'll keep that the same. Equals 35. And when you added those up, then what happened?
The x's canceled.
Yep, x's are gone.
I got -49y.
49y.
And then that equals -98.
Negative 98. All right, and your last step?
Divide by -49 on both sides.
9.
And that means y equals 2.
And we got y equals 2. Yes, perfect. So you got y equals 2. And now, which one did you plug back into to find x?
I plugged it back into the first one.
Back into the first one. Okay, so we'll fill that in right there. And when you filled it back in, 8 times 2 gives me how much?
16.
16. And when you finish that up and solve for x,
X equals 3.
you got x equals 3. Perfect. Any question on that one? All right, let's look at the next one, which this is a solve by graphing. So when you are graphing, what are you looking for when you draw 2 lines in terms of the solution? You're looking for
Where they cross.
where they cross. Now I've already drawn the picture for you, so you don't even have to sketch it. That is the picture. So if you had to estimate where they cross, assuming it's a nice number, what would be the coordinate where they cross?
2, 1. Or 2, -1.
2, -1. And if we check it, 3 times 2 is how much?
6.
6. And 4 times -1?
4. Wait, no, 4 times -1?
Yeah.
-4.
So it's -4. And 6 minus -4, that's 10. And the last part, what's 2 times 2?
4.
Plus -1. And what's 4 plus -1?
3.
Perfect. So that is the solution. Okay, so here's another one, solving graphically. Okay, so to solve this one graphically, I didn't give you the equation this time. So what are you going to have to do?
Find the point doing. I mean, could you make it so the y at the bottom is on its own side?
Yeah, we could get y by itself in the bottom. If you did that, what would this turn into?
Y equals 3 minus 2x, or -2x plus 3.
Okay, so there's one of them we're going to use. Here's the other one. And what do we want to do now?
to the y equals,
Okay, so go to y equals.
and then
Make sure we are in function mode. Okay.
and then you would put the first equation in.
Yep, remember E, that's a special number we talked about when we did
Yeah,
logarithms.
it's second, and then it's the one that is like the arrow pointing up kind of thing.
The one right below.
The one, oh yes, the one
The
right
divided
below.
by.
And then you would press that one, and then put 2x plus 3.
Okay, so there's our first one. That's an exponential equation. So it's going to curve up very, very quickly.
Yes.
And the bottom one,
And then
that's,
negative 2x plus 3.
okay. Is that one exponential?
No.
Negative 2x plus 3? No, what's that? What kind of equation is that one?
That's just like a normal slope, kind of.
So what shape would it be?
A line.
A line, yeah. So we just got a graph that's going to curve up sharply.
So there's 2 spots that it might cross.
Yeah, if it does it just right, it could hit it twice. Let's see. I mean, it will hit it twice. It's just a matter of,
How far out?
yeah, I think, let's just try zoom 6. I think we're going to be able to see maybe both spots. It's still drawing. Oh, right, because it's a negative slope, it's going to come down the other way.
So it's only going to cross once.
Yeah, so it is only going to cross once.
Okay, if it was a positive, it may have crossed twice.
Yeah, if it's a positive slope, it could cross twice.
Or it could cross not at all.
It could cross not at all if it was down in there, or it could be like tangent and just cross once,
Yeah.
which would just touch it once. But yeah, this one only hits once. Okay, so how are we going to figure out where that is?
Second, calc, intersect.
Intersect. Yep. And we'll just hit enter, and
That's fine.
there's your answer. Okay, so to solve a system graphically, we just have to see where they cross. Okay. Any question on that one? Okay, so the next one is a matrix problem, okay, using Gaussian elimination to solve. Okay, do you want to take a look at the matrix problem? Okay, so let me just see what we got. We got that one, and then this is going to be another matrix problem, but maybe we can just set this one up.
Yeah.
Because it's going to be, I mean, it's up to you. We could do 7 or we could do 8. Do you have a preference on? Both of them are going to be with a matrix. 7, you don't have to set up the equations.
I would rather do 8.
Okay, because you got to set them up yourself. All right, so let's do 8
Get
then.
2 done in the same thing.
Yep, get them both done. All right, so the first thing is we need letters to represent our 3 numbers. What do you want to use for letters?
X, Y, and Z.
Okay, so X, so I'm guessing is the first, Y is the second, Z is the third. All right, so the first sentence is the sum of the 3 numbers is -4. How could we write that with X, Y, and Z?
-4 equals X plus Y plus Z. Or, yeah.
Okay, so there's your first equation. The sum of the numbers is -4. Second equation says the first minus the second. So let's start with that.
Okay,
What's the first?
X minus Y
Minus the second.
plus 3 times 3Z.
Plus 3 times the third. And what does it say that equals?
-2.
Okay, so we got -2. And the last one, the third plus 3 times the first plus the second. Okay, so I'm going to do this one off to the side because they're not giving it to us in the order we want, so we're going to have to fix it. But let's write it down the way they told us.
Z plus 3X plus Y.
Okay. And now let's fix the order on that so it's X, Y, and Z. What would come first?
3X plus Y plus Z equals 2.
Okay, so now we've got our equations ready to go. Okay, if we're gonna solve it with a matrix, that's the first thing. We wanna write everything down as just numbers without letters. So I'll copy, we don't have a ton of space. So you know what I'm gonna do? I'm gonna take all these and I'm just gonna make them a little smaller and move them. Okay, let's put those up here. Okay, what's gonna be the first row in my matrix?
1, 1, 1.
1,
And then negative
1, 1, negative 4. Yep.
And then 1, negative 1, 3, negative 2.
Okay, and my third row?
3, 1, 1, 2.
Okay. Now, when we're doing a matrix, the first thing you want to do is get what number in what spot?
You want to get the top left to be 1, which it already is.
Top left, we want it to be a 1. It already is, so we can skip that
And
step.
then we want to get the row below it.
Okay, what do you want in the row below?
The one right under the first one
Yeah.
needs to be a 0.
We need to turn that to a 0. And what else are we going to do at the same time?
Turn the 3 into a 0.
Which one? This one?
No, the one on the bottom.
This one.
Yes.
So we want to get zeros in those two spots. So the first thing I always check is, can I just add the equation to the other equation and just have it work? If we add them together, the first one and the second one, do we get a 0 in that spot? No. So can we multiply the first one by a number and then make it a 0? Yeah, what could we multiply it by?
A negative 1.
Yep, so we'll do negative 1 times the first equation. We're going to add that to the second. And where are we going to put that answer?
In the second.
In the second row. Okay. Now, if we add the first to the third, do we get a 0 in that spot?
No.
No. So what could we multiply the first by to make a 0?
A negative 3.
Negative 3 times the first plus the second.
Plus the third.
Oh yeah, plus the third. And where are we going to put that answer?
The third row.
In the third row. Yep. All right, so now let's do that and see what we get. So multiply everything by negative 1 and then add it to the second. Okay. What's 1 times negative 1?
Negative 1.
Plus 1?
0.
0. That's a 0. What's 1 times negative 1?
Negative 1.
Plus negative 1.
Negative 2.
Negative 2. Okay. What's 1 times negative 1?
Negative 1.
Plus 3.
2.
2. And what's negative 4 times negative 1?
Positive 4.
Positive 4 minus 2.
2.
2. And the fact that all those are 2's, that's going to make the next step easier when we get to it. Okay, so now multiply by negative 3 and then add to row 3. What's 1 times negative 3?
Negative 3.
Plus 3.
0.
0. And 1 times negative 3?
Negative 3.
Negative 3 plus 1?
2.
2. And the next one's going to be negative 2. Next one's also going to be a negative 2 because it's the same number. And then multiply negative 4 times negative 3?
Positive 12.
12 plus 2?
14.
14. Okay, so now at this step, the only numbers that should be changing are what are in that blue box. Nothing on the outside of it should be changed ever again in this problem. Okay, what is our next goal? We want to get a what?
We want to get a 1 in row 2, column 2.
Yes, we want a 1 in this spot right there. How could we get a 1 in that spot?
Multiply by negative 1 half.
Multiply which row?
Row 2.
By what again?
And negative 1 half.
Negative 1 half, yep. Which two rows are going to stay the same this time?
The first and the third.
Yes. So let's take negative a half times row 2, and that will replace what's in row 2. I like to copy everything that stays the same. 1, 1, 1, negative 4, 0, negative 2, negative 2, 14. All right. What's 0 times negative a half?
0.
What's negative 2 times negative a half?
1.
1. And 2 times negative a half?
Negative 1.
And 2 times negative a half again.
Negative 1.
Okay, perfect. So now we got a 1 right where we want it. We have to do one more step, and that's going to pretty much finish up our matrix. What's the last number we want to get, and where do we want to get it?
We want to get the negative 2 in row 3, column 2 to be a 1. I mean a 0.
We want that to be a 0. Yep. Okay, so now to make that a 0, look at the row immediately above it. If we add row 2 to row 3, do we get a 0 automatically? Nope, then we got to multiply first. What could we multiply by first?
2.
Yep. So 2 times the second row. We're going to add that to the third row, and that's going to replace what's in row 3. So which two rows stay the same this time?
1 and 2.
1 and 2. 1, 1, 1. Negative 4. 0, 1, negative 1, negative 1. Okay, so now we double everything and add it to row 3. If you double 0, you get
0.
plus 0.
0.
Stays the same. If we double 1,
We get 2.
2 plus negative 2.
0.
0. And negative 1 times 2
Negative 2.
plus another negative 2.
Negative 4.
Okay. And negative 1 times 2?
Negative 2.
Negative 2 plus 14.
12.
12. Okay, so we are done with our matrix. We've gotten it the way we want it. We want to take that last row and translate it back into an equation. What does that last row tell me as an equation?
Negative 4z equals 12.
Negative 4z equals 12. Yep. So now we can solve for z. What will z come out to?
Negative 3.
Negative 3. Yep. Okay, so now we got z. We're going to work our way back, and now we're going to get y. What does the middle row tell me?
That y minus negative 3? Or would it be just minus? It would be minus z
Minus z
equals negative 1.
equals negative 1. Yep, so y minus z equals negative 1, and z is negative 3. So when you fill that in, what happens?
It becomes a positive.
Yep. So you get y plus 3 equals negative 1, which would mean y equals
Negative 4.
negative 4. Perfect. So now we got z, we got y. Last one we have to find is
X.
x. All right, for that, we're going to go all the way back to the first row. What does the first row tell me?
That x plus y plus z equals negative 4.
Yep. And we don't know x, but what did we get for y?
Negative 4.
Negative 4. And for z?
Negative 3.
Negative 3. Okay. What's negative 4 minus 3?
Negative 7.
Perfect. And if we get x by itself?
It would be positive 3.
Positive 3. Okay, so that covered basically using the matrices and setting up the equations yourself. Okay. Any questions on that one? Okay. All right, the next one we're going to look at is writing out terms in an explicit sequence. So all we have to do is take the number of the term position, plug it in for n, and that'll tell us our first term all the way through the fifth term. So if you plug, what number would you plug in right here if you want to find the first term?
1.
1, yep. And if you do that, you would have 1 minus 4,
So negative 3.
which is negative 3. And let's just check one more just to make sure we didn't make a mistake. If you want to find the second term,
Put in 2.
put in 2. 2 minus 4 gives you
Negative 2.
negative 2. So I think we can see at this point which one it would be. Which one is this?
A.
Yeah, so this one is A. Those are the first 5 terms in the sequence. Any question on that one? Okay. Let's take a look at this one. So this is one I'm going to clarify too when we do the homework. If a sequence converges or diverges, diverges means that the numbers are getting closer to infinity. That's what diverges means. Converges means the numbers are getting closer to a value. So I'll give you an example of one that converges in a second, but let's look at this one first. As you look at these numbers, what's happening each time as you go from left to right?
They're getting bigger.
And specifically in what, how?
They were being multiplied, I believe.
Yep, by how much?
4.
4. Yep, they're being multiplied by 4. So, because there's a dot, 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 means the pattern goes on forever. And if you just continued multiplying by 4, and then times 4, the numbers just keep getting bigger. So we are not approaching any value. We're approaching infinity. That means this diverges. Okay. So this one diverges. Can't give the limit. The limit would be what it's getting closer to, and this one's not getting closer to anything. But let's look at this one. Let's take 24, 12, 6, 3, and that should be enough for you to see the pattern. What's happening as we go from 24 to 12, and then 12 to 6, and then 6 to 3?
We're halving.
Yeah, we're taking half of it. If we continue doing that forever, will we get close to a number? Yes, we will get close to a number, but we will never reach the number. That's why it's called a limit. It's just the number we get close to. What number do you get close to if you keep taking half?
Wouldn't it be 0?
Yeah, so the limit of this is 0. Okay, if you keep dividing by 2, you can see it's getting smaller and smaller, but it'll never, will it ever be 0?
No.
No, it'll just get really, really close to 0, but it never actually will come out to 0. So this one, you would say converges. The limit is 0. So I'll clarify that when we go over homework tomorrow. But any question why this one diverges and this one converges? Okay. All right, so the last two we're going to look at are taking a sequence of numbers and writing an explicit formula. So in the first one, they tell you it's an arithmetic sequence. So what is the formula that we use to convert that into an explicit equation?
8 plus, in parentheses, n minus 1 times 3.
3, yep. So the formula is the first term plus n minus 1 times d, and d is what you add each time to get from one number to the next, which is 3. Now, we want to clean that up as much as we can. So when you distribute it, what's 3n?
3n.
What's 3 times n?
3n.
Yeah. All right, so 3n. And then what's 3n? What's 3 times negative 1?
Negative 3.
And negative 3 plus 8?
Positive 5.
5. And there we go. So that's an explicit formula to calculate the terms in that sequence. Now, the bottom one just says find an explicit rule for the sequence. They do not tell you the type. So is this the type where you add the same number each time, or you multiply?
It looks like you're multiplying
Yeah.
by 2 each time.
And if you're multiplying, do you remember the name of that kind of sequence?
The geometric.
Yep, geometric. All right, so we've got, it's a geometric sequence. What's the formula for the geometric sequence?
AN equals 2 times R.
And what's R in this case?
2?
2, yeah. So this is a 2 because it's the first term. This is a 2 because
it's multiplying.
it's what you multiply by. Yep.
And then it would be N minus 1.
Yep. So that would be your formula. And technically, because these two numbers came out the same, you can combine them. All right. What happens when you have two things with the same base and they're multiplied? What do you do with the exponents?
Don't you add them?
You add them. You can only do that if the bases are the same.
So it would just be N.
Yes.
So it would be 4 to the power of N.
So when you combine them, the base stays exactly
It
the
would
same.
be 2 to the power of N.
2 to the power of n.
Okay.
That's a simpler way to say it.
Okay.
The top one's not wrong. It's not
No.
simplified, no. Yeah. Okay, any question on that one?
No.
Okay.